All right, everybody. Welcome to this month's version of Unboxed Technologies Dev Talk. We are at our new location in Scott's Addition. So if we're having any technical difficulties, try to let us know either within the YouTube chat or the Hangouts chat. I'm going to be monitoring those. So if you have any questions throughout the talk, feel free to ask questions there. Today's talk is by our very own Nick Capito. He is the Vice President of Software Engineering, and he's going to be talking about refactoring old code, which we all need. Just a little plug, don't forget that these dev talks are once a month, I think the second Tuesday. Next month will be by our own Hayden Braxton, another software engineer here. We'll have more details about that as we get closer. But without further ado, here's Nick. Hope all the audio is good. And let me switch over to his presentation.
Well, awesome. This will be my first presentation where I can't see anybody if they join, which might be a good thing. But Kevin, can you hear us? Assuming so.
Yep.
Awesome. So you can be our red flag if anything goes down. So I will say, like, when I was doing this talk, I don't know if I was procrastinating or what. I decided to try I decided to pick an alternative to Keynote, which is my go-to, and I tried this product called Slides.com. So I have the link for anybody out there. I guess it's just Kevin that could follow along on the live site. It's down at the bottom, but you should be seeing what we're seeing. And it also allows you to put comments on there. If you see something in this presentation you want to follow up on, feel free to comment, and I'll go back and respond to it. We'll see. Hopefully nothing goes wrong. I'm pretty excited about it. So the first thing I did after choosing this topic was I quickly tried to get out of it. For good reasons. Like, I'm very passionate about this subject. I always have been, and I always will be. Refactoring is something that we need to do throughout the life cycle of a product, but I don't think it's something that's really easy to teach. So when my first instinct was, I'll just list off my thoughts on it or the things I do, which come to find out it's really hard. Hayden encouraged me to continue, so I did. I'm pretty excited about the talk, and there's a lot of content here. A lot of it lends itself to discussion, so feel free to chime in and ask questions, and I will do my best to mediate. So let's do this. So it's happened to us all. You've always had that influx of errors, like something's happened. All of a sudden you see a spike, site goes down, you get an email, and then what's the first thing you do? You start looking at the code, you find it, and you say, oh no. You do the get blame, and you just cross your fingers, and you think, man, I hope this isn't me. And you look back in time, and at some point you'll see code that you've written, somebody else has written, and you just think to yourself, like, man, like, what was I thinking at that time? Unfortunately, we've all been there, we've all done it, and half the time we can't remember why we did certain things. And this talk is all about teaching you guys that it's okay I want people to be more open to the idea of refactoring. I don't think everybody out there, when they open up a block of code, goes into it with the mindset that, hey, I could change this code if I really need to. So that's the mindset I have, and my mission in this talk is to teach you guys a new way of looking at approaching incremental refactoring. So this talk was heavily inspired by Martin Fowler. Rick let me borrow this book. I bought this book 2 times. I'm probably going to buy it a third. I'll pass it around for the guys that want to see it, and I do have a link at the very end of the talk. I will speak this in the book, but this was a vital resource in this presentation. There's 2 different presentations he's given as well, similarly. Definitely, if you're looking for more details, this is the best resource we have in-house, and I strongly recommend reading it. I have the link down here at the bottom to the YouTube video, but let's do this. So I want to start off with a question. If you came across like this block of code in a file you were looking at, what would you do? Who here would remove it? 1. maybe.
I would eventually.
Yeah, depends on how long I sit there and look at
How
it.
long it annoys me.
Yeah. What about you, Kevin? Did you remove it? Did you leave it?
It would depend on what rush I'm in, and do I know any context, or can I find any more context about it?
I got you. The other question I had, would you format it? Like, if you saw that, would you do anything with formatting? Assuming you didn't remove it. Would you care about formatting? Yeah. Some of this takes context. Anything else you might do if you saw this was good? There's no wrong answers here.
What else is there to do?
I don't know. You see this block of code somewhere. Any other reactions you have besides deleting it?
I mean, I'd look and see who did that. Yeah, maybe ask them why.
Like I said, there's no wrong answers. We'll come back to this 10, 15 minutes from now, and we'll ask the same questions, and we'll see if I was able to change your mind about anything. So I'm going to use the term bad code a lot here, and I don't want anybody to think it's a negative thing. We all do it. I've done it. I've seen this little the only valid measurement of code quality is WDS per minute. I definitely think it's funny. It's not obviously a real metric, but when I see bad code, I usually find myself thinking like what on earth is going on? And then I start trying to sift through what on earth is going on. At some point you get to a crazy mousetrap. Another time you're like, what on earth was this thing doing? We never know what happened, but we just know when we see it. And the experience is not exactly ideal. So how does it happen? We don't intentionally do this. So like, if you guys had to guess the number one reason or your top reasons code goes south, what would be your number one?
Time.
In a hurry. Rush.
Hurry.
Yep.
Patrick, you got one?
That's what I would think of.
Time or in a hurry. It would be on my top list. But I think the other thing we tend to forget about is sometimes bad code is bad because we don't know it's bad. So it's a new technology, a new piece of software. We haven't used it often enough. And by the time we look back on it a year later, we know so much more. So that's what makes it bad. So context is important. The other big one for me is also bad habits. So sometimes lack of accountability can cause bad habits. So if you don't have tools to help hint your code or code reviews or things like that, that can also allow people to be a little more lazier than you want. You guys mentioned lack of time and rushing. Another one is bug fixes. When people go in and fix bugs, they don't often put a lot of thought into it. They want to get in and fix it, and at the end, you start getting patchwork all over the place. You start taking the minimal amount of work to get it working because maybe you're afraid of breaking something. And the last one I want to call out, this affects us a lot, is every now and then if you have a new product, changes in direction of where you're going can also inadvertently cause bad code because you don't actually ever get to fully flush out an idea. Maybe you start it, a month later you maybe come back to finish it, and you don't feel like cleaning it up or whatever. So there's tons of causes out there. We're never going to be able to stop it. So the idea is we need to start thinking about how can we fix this moving forward. I just want to take one quick moment here to talk about some terms I'm going to use. Today I'm going to talk about a couple of things. One is refactoring. We've all heard the word, but the actual formal definition of refactoring is a process of restructuring existing computer code, changing the factoring without changing its external behavior. The idea is you're not really changing outwardly what it's doing, you're really just reorganizing internally for different reasons, which I'll go over. The other big debate's always rewrite versus refactoring. I don't usually advocate for rewriting, so I'm not going to go over that today, but just know that if you ever hear somebody talk about rewriting something, it is different than refactoring. And the other two big things are legacy code. If I use the term legacy code today, the definition I'm using is code that doesn't have test coverage. There's different definitions out there, but that's the one I tend to use. And the last is code smells. Code smell is just basically something that's hinting toward a deeper problem. So we'll go over a lot of these terms, but they're definitely things we want to get familiar with. So the last piece here is this is kind of just the, I want to say about a year ago, I read this quote, and it really changed my mindset on code from writing to reading. We read code 10 to 1 more than we write code. So if you can improve readability, comprehension of code, you're in theory going to make it easier to write code. So I say this because I want, like, some people get attached to their code, and if they see somebody else changing other people's code, they get kind of defensive. But just know that, like, believe in the positive intent. Like when people change code, if you have good practices in place, they're changing it usually to make it more readable, and they're changing it for good reason. So I guess the takeaway here is don't get attached to your code. So what I'm going to do now is I'm going to jump in. So I've been talking a lot about refactoring. There's about 5 different buckets of refactoring, reasons to refactor, approaches to refactoring. And I just kind of want to walk you guys through them. And at any given time, if I'm moving too fast, slow me down or ask me a question. So refactoring techniques. Again, my thought here is I was going to pull up some code that I refactored and just show it to you guys. Be like, hey, here's what I started with and here's where I got to. I'm going to give you some examples at the very end, but I quickly learned that the approach is much more important. It was the reason I was choosing a refactor that was missing, and that's what these techniques go through. So the first major category is litter pickup. I usually refer to this as the Boy Scout rule. The idea is, like, you never know what happened, right? We saw some dead code earlier. You might see some comments that were out of date. You might see methods that aren't used. The idea is that as you're going through, like, don't be afraid to clean up. Don't be afraid to remove dead code. We have Git out there to figure out where the code went. Don't be afraid to reformat files if you have a style guide. The general idea is, like, as you're going, like, don't be afraid to just fix it. These are usually really low risk, mostly cosmetic, and these are, you could walk out here tomorrow and commit to this. So the next category here is comprehension refactoring. I really love the code review comic here. Is there's so many times where, like, you look at code and you're just like, I have no clue what this is doing, and they just jokingly say, hey, just ship it. We don't have to worry about changing, like, making people not be able to comprehend this thing. So the lesson here is it's really easy to write something that achieves the desired output. It's really hard to do it in a way that's simple and also comprehensible. So the first true test of code you write after you get through testing is that somebody else can actually maintain it and change it. My triggers here, the code smells, is whenever I find myself working really hard to understand what's going on. You hear me grumbling, I might say, seriously, what the heck? If I ever say that out loud, I'm experiencing this, and I'm basically working really hard to understand code. And the lesson here is, like, if you're going to spend that much time trying to comprehend it, you are in the best position right after that moment to actually clean it up and make the next person be able to understand it just a little bit more. I think what we usually do is we get through it, we finally understand it, we make the change, we move on, versus taking it that one little tiny step further to actually make it a little more readable for other people. And again, we'll go through some of these, but I will say of all the things I do, of all the techniques I think scare people the most is people that, people are more likely to move a file, remove dead code, but they're less likely to actually try to refactor something to make it more legible. And this is a harder one. So this is kind of like there's simple and there's intermediate. This is definitely a harder one, but this one takes time and it takes practice. And there's also times where you can refactor it just to do it, to get better understanding. You could discard it at the end if you wanted to, but this is the one you have to work toward, and it becomes much more natural as you get more comfortable with your code base. So the other one, I didn't really talk about this one too much because this should happen naturally. Code's usually written for one purpose. The second somebody comes in there and asks, hey, can it do that? You might have to go in and change the structure to make it easier for you to write your use case. So this one, we should be doing this naturally. You need to add a new feature. You see that the thing's built for one purpose. You need to enhance it to do something else. So I'm not really going to touch on this one because this one just requires you to do the right thing when you develop. So I'm not going to get into it. Planned. These are the most dreaded ones for me. I refer to these as really big refactoring efforts. The idea here is you've hit a point where you have to now go to your product team and say, hey, this code is so bad, we need to just take a sprint and clean it up. This happens all the time, but if you actually use the other techniques, your code is incrementally going to start fixing itself. And when you get to this point, this is the nightmare scenario. You know, one team is out there adding new features, and you're out there trying to clean up existing ones, and then you're also the one behind the scenes trying to deal with all the conflicts. At the very end, if we have time, I do have some. If you find yourself in a situation, here's some tips. But just know that if it's gotten this far, there's probably a bigger thing going on, and you're not practicing some of the other techniques I'm talking about. Lastly, long term, these are actually much more peaceful to deal with, because this is kind of like the team sits down and they say, hey, we're using this thing called OData. This is a real life situation. We're using this thing called OData. It was really meant to be used to be quick and dirty, to get us off the edge of the pool quickly. But we've reached a point now where it's actually causing us more harm than good. Let's come up with a plan to get rid of it. So like your team, whiteboards figures out, all right, we're going to replace OData with this new pattern. And then over time, you come up with a strategy to slowly phase it out. You don't do it all at once, but as you touch this block of code, I'm also going to phase out this technology. Same thing with put or patch. One of our other products is going through a transitional phase where we're thinking about not using put as much, because we can do everything with a put we can do with a patch, and the patch can also be used with a subset of fields. So this one's a very powerful one, but it does require the team to all be on board and align on where you want to go. So that is the last of all 5. So I do want to take a moment, take a breath, and see what type of questions you have based on those 5 different techniques I just talked about. Any questions? Anything new? Is this all things you guys have already known?
Well, we're currently reading a book right now called Clean Code, and a lot of these have been popping up. So it's been some good context, because I know we've experienced a couple times. We each have our own style of coding.
Yeah.
So I think kind of coming up with a good standard, some kind of style guide, which we I think we currently have some of those, would always kind of help steer that to a little bit more legible code.
Do we do these things?
What was the question?
Do we practice these techniques?
Sometimes.
I think recently too, it's when we plan for a story, we talked about giving ourselves a little bit more time, plan for a little bit extra time so that we can refactor anything that we come across as we come across it. Because I know I've been looking at some of my code recently and fixing it as I go.
That's awesome. All right. Cameron, you got any questions? All right. All right, well, I'll keep going. So what I want to do now is I want to transition to, kind of already asked the question, the question's still out there, you see this block of code, would you do anything differently? I didn't give you the answer earlier, but if I saw this block of code, the first thing I'd do, before I deleted it, this is the first code smell I would see. If I came to a section of code that had this much commented out, there's some story out there on why this might still be there. I think Kevin mentioned he might ask more questions, or maybe it was you, Kyle. I might start asking some questions. I would probably do a git blame. Definitely be searching around. But this would be my first red flag that there's probably something else going on, that before I touch this block of code, I need to get a backstory. So the key thing here is we can't be afraid to make small changes to make things better. We need to create a culture that fights back against software entropy. It's the first time I've used the word software entropy. Has anybody heard of that before? It's this general idea that anytime a software system is modified, the disorder, entropy is the amount of disorder within a system. The idea is every time you modify it, the system gets worse. Every time. It's so the only way you can combat that is to counter that with good habits like this, where every time you make a change, you're also making something else better. So your system naturally gets better over time versus decaying over time. And then the cost of change doesn't also trend downward with it. It's just that allows you to achieve a sustainable rate and not slow down over time. So it's really vital that we start practicing these techniques. And I will say over time you just start doing them, because you get faster, you get more comfortable with the code, your knowledge increases, your skills increase. So I'm not saying we don't do these things. I think we do them, but yeah, just know we need this to fight back against billing software. So like the last thing I want to do is, before I move on to examples, is take you through what I would do. And this is really just summarizing. So somebody comes to me and I'm just kicking off a new feature or even fixing a bug. My process is pretty basic. Before I touch anything, I first do an assessment of the code I'm changing, where it's being used, and how it's working. And I also get some background knowledge about the problem I'm trying to solve. But when I'm actually doing this and as I'm trying to get an understanding of the code, I'm taking notes on things I see, any type of particular code smells. I do a bunch of, that's why I put that at the bottom, a bunch of like find in projects, command Ds, you basically get an understanding of where it's being used. And then I start documenting the things that I think I can fix right now or have time to fix. Step 2 is the most important piece because every time you see a block of code, you could always change something with it. But the idea here is you have an opportunity to add a new feature or incrementally fix something. You also know with that comes testing. So you kind of have a rough idea of your blast radius and that if I add this new feature, QA is probably going to test this block of code. So why don't I go ahead and just make this section of code better? So then you can also test it yourself. But when you submit to QA, you also know that somebody else has got eyes on it. So it really is a really efficient time to change existing code. And the best time to find these things are when you're actually trying to figure out what the code's doing. So basically, I get comfortable with the code, make the change I want, I test it, I commit it locally, and then once all that's done is when I actually then will go in and make whatever change I originally wanted to do. So there's nothing magical about that, but I do think that for me, steps 1 through 4 is a prerequisite for me to make any type of change because I know the second I touch it, I'm now associated with that file, and I want to make sure it's in the best state I could. So, all right. So the only other thing is, like, as I'm going through that step number 2, the things that really set off red flags for me are lots of comments. The more comments you see in code, either the more tricky the logic is, maybe the algorithm or the reason behind doing something might have some secrets in them. Dead code, if I'm working through a code base that has tons of commented out code or tons of unused things, kind of hints to me that something else is going on. Either lots of stuff are changing or I don't even know, maybe things need to be removed, maybe it's overly complex. Really large files is the easiest one to find. Is you have a file that has like 4,000 things in it, 4,000 lines in it, probably could break that down a little smaller. Too many parameters coming into a function. That having to make one change in a bunch of places is actually called shotgun surgery, which I never knew before creating this presentation, but the idea is one little small change all of a sudden is hitting a bunch of different features, and you have to go in and change all those different features. And then the last is whack a bug. If there's a bunch of sections of code that you see or your team is experiencing bugs keep popping up, there's something going on in that file, and it is a target to clean up. So definitely shotgun surgery was a funny phrase that I came across. And the last thing is just these are the things that, so when I was originally creating my dev talk, this was the list of stuff that I knew I did every single time. When I find myself in a block of code, like I have a really hard time not deleting dead code, removing comments that are invalid, simple renaming of functions, like I will do in a heartbeat. Like if somebody's named something I and it should be called user or something like that, I'll do it because those are really cheap and really simple. Splitting functions into smaller pieces. I think Obey taught me that. Originally I was like, oh, this function is too simple. But as your functions get smaller, they get less responsibility and their purpose is much easier to see. And then the counter to that is sometimes I will consolidate functions that are too simple. If you've added complexity for like a simple statement that's never used again, you can actually make it harder to comprehend because now the person has to go find that function and figure out what it's doing. So there's some secret sauce there. And then I should have put these in a better order, but centralizing change, another thing I like to do is if I see state is changing at the same time but in different places, I will put all that code together. And then the last 2 pieces, whenever I'm dealing with a function, if I see a lot of returns from that statement that aren't structural, I will clean that up. And then the last is if there's a bunch of nested if-elses, if there's simple ways you can reduce that complexity, I do that. So this is my short list. These have become habits over time. I have no clue why, but I do know that when I think about code I touch and I'm in charge of maintaining, the first thing I do is I go through this list. and this is probably the most opinionated section of this talk. It's all opinionated, but this is the stuff that I have a hard time doing, and I would have a hard time stopping doing, because in my opinion, in my belief, this is making the code easier and simpler to maintain over time. But yeah.
So as you were saying, like if you had a store to go in and fix something or fix a bug or whatnot, you actually don't actually do that code or that story first. You do your refactoring like around it, and then fix your.
So this would be step 2 up here. So like if I find these things and they're touching sections of code that I know I'm going to be needing to deal with or use, and I've identified maybe this is hard to understand because of the way it's structured, I'll go ahead and do that, and I'll test to make sure it's stable, and then I'll make my change.
Okay.
So a lot of this just feels like reduction for me. Like I don't know if it's part of like math history or what, but I feel like sometimes I'll get into code and I'll see that there's ways to collapse logic, and I'll show you some examples, and it just makes the function seem tighter and there's less to read. And it is opinionated, but I think at the end the goal is rebuilding, and hopefully I'm not causing more work than good. But
that was one of the things we talked about recently too. Is if you do see comments that suggest that things aren't named correctly or structured correctly, because it's not legible, it's not easy to understand.
The key is low value. There's a lot of back history to every line of code we write, so I don't go and read everything. But when you see comments that are basically just saying the same the function is, they're just adding, they're not adding any value. So to me, they can be removed. And I did put a note in here is just because I fix these things doesn't mean I don't do these things. I am very there's lots of to-dos Nick out there. So I will say that I definitely do these things, but they're not. I'm never proud when I leave these things behind. So, Kevin, do you want to say something?
Yeah, just thinking on the comments, we could have an entire talk probably about those. What is a high value comment, a low value comment? I try not to be afraid of putting comments. I'd rather err on too many than too little, because a lot of times it is backstory or trying to reduce how much time you spend trying to read something. So don't just say, don't repeat the if statement in text, but if you can give any context that might help the next person, comments are cheap.
Absolutely. I think my biggest complaint about comments is if you don't draft the comment and you're not committed to cleaning them up, they sometimes rot really quickly. I know for me, I'm hyper-focused on the code, and I don't always look at those comments that are slightly harder to read. So, but I'm 100% for you.
True.
Any other questions? No? All right, so the last thing I was going to do is this fancy book over here that Kevin can't see, but he can see it now. Basically goes through and documents every discrete step you could take when refactoring. So one of them is like encapsulate field, or it's extract method. The idea is these are steps you'll take along the way, and it kind of gives you a high level idea of when to use it, but you could not read this and then know when it's time to do it. It's the best way I can describe it. It is a really awesome resource, and what I found is it was easier for me to go back and like retroactively see the changes I made and map it here. But when after I read this book, I didn't. As I was doing, I was like, oh, I'm doing this right here. It was just kind of like it. I think it opens your mind to different other ways you can refactor code. So I pulled out my top 4 that I did, and I tried to give examples, and they're all made up. So do not try to like rationalize whether or not they're truly like real use cases, because it's really hard to come up with these that are simple and easy to read. And all the ones that are actually from refactoring.com down there are examples from the book. But the idea here is on the left-hand side, this is one I do a lot, is if you look on the left-hand side, there's a lot of nested if-elses. And the way that you replace nested conditional with guard classes is that actually you'll see it's returning. And when you add that return, you can get rid of all the else statements. This is another one of the secret sauces, because another problem you can cause if you have too many exits from a function, it's hard to comprehend. But when you have something as clean as this, where the entire function is following the same format, you know that after you can't see my cursor, either one of you, you know that after you get out of that second if block, if you hit that return, you don't need the else anymore because there's no way to get to it. So you can remove all that boilerplate code, and it's much easier to scan, it's much easier to breakpoint and debug. So this one I find myself doing a lot. And it's pretty straightforward. So the idea is they anywhere they were setting that result, instead of setting it, they're not returning it. So Kevin won't be able to see my cursor, but does that make sense? I do this one a lot. One of the things I do the most is if there's an if else out there and you can invert it in a way that it's kind of like a base condition for a recursive function. If there's an easy exit that makes your complexity less, go ahead and add it at the top and then let the rest of the function flow smoothly. Oh gosh. So the next was conditional simplification. This was actually a combination of 3 different methods out there. The left-hand side, you'll see there's a lot of similar return types. So if I'm looking at this file, I can kind of see that there's probably something similar about these 3 things. And the idea is I would have seen that I would have reduced them into one section, and then I would add a function actually define what I'm doing. So instead of having these random booleans you don't really know what they're doing, you give it a business-specific function name, and now you're saying, like, instead of, it's not a senior, it's like, can I redeem this thing? And then you also consolidate the logic, so it's not duplicative. And the last piece we're starting to see is decomposing conditional was this first piece. And sorry, this was the consolidate duplicate conditional expression. And this piece right here is taking this complicated thing that people don't really understand, and again, making it much easier to comprehend. I'm not going to touch this thing yet.
Cursor's not showing up.
The other piece there, as you see, we pulled up and gave, instead of just having these random business logic, we went ahead and gave it a function. So we put it into a method and we gave it something that's much easier to read. And then we also saw this send was duplicated, so we pushed it to the bottom. So the right-hand side is much easier to comprehend. It reads much more cleaner. You don't need as many comments. And these functions all have very specific purposes, and it'll be easy to know what to change and what to change.
Cursor doesn't show up, but if you highlight it, it does.
Interesting. All right.
FYI.
I'll try. It's hard to go back and forth.
Yeah.
All right, so these get much harder because it's easy to get these examples, but this implies that you have control over the code you're changing. I actually see this a lot. People that'll take properties from one object, copy them to a variable, and then pass those individual pieces to a function itself. The idea here is before we started the first example, we basically just need these 2 properties and we're passing it to a function. Instead of doing that, just pass the whole object to the function and let the actual function get the properties it needs. Because usually what's happening is you're dependent on a data type versus actual properties, and this allows you to pass the whole thing there and you don't have to worry about, like this function really doesn't care. This function really doesn't care about the parameters, it just wants to call this within range. Parameterized method, just whenever you see functions that are doing really similar things, but you see a couple of methods that are maintaining it, you can basically collapse these into a single function that can be tested once. Again, this is a made-up example, but the idea here is similar logic, easy to consolidate. And this is another secret sauce moment because you can actually, when I say secret sauce, it means it could be good and bad. By combining these into one, you now make it harder to change this function. So like, just know that all of these come with a cost. The more you abstract something, the higher the cost of change. So just know that it would be easier for you to change this logic, but it also is harder to read at times. And the last thing is anytime you have getters and setters for private methods, basically, I'll remove them because you're putting out mixed messages. If you have something internally that's only used internally, but for some reason maybe your editor or you just naturally add getters and setters for everything, they're not needed, and they're more things that consume in a file. So like if I see blocks of code that are only used once or set once, I'll go ahead and remove that just so people don't have to worry about trying to understand when it's used. That's it. I think like for me the biggest thing is removing dead code, making things more readable, simplifying conditional logic. I'd say 90% of what I do is that. And there's a bunch more. So everything in this book, you'll see, lagging miserably. Wow, I can scroll. Interesting. So I have to scroll here. But this website's out there. It's basically for every single one of these. You can click on it, and it gives you the description of it, and it can even give you the samples. So it's nice. It's definitely not the most attractive site in the world, but it's functional. So.
And we'll include that link in the YouTube.
Yep. These are all at the very last thing. I have a slide that talks about this. So I promise we're getting close to wrapping up. So the key thing here is you have to just start. Practice makes perfect, and my recommendation is you start simple, right? So the stuff we're going over here is the simple stuff is the litter pickup use case we talked about earlier. Simple name changes, removing dead code, method splitting, formatting code. It's a really easy cosmetic type things, but they go a long way. The more intermediate is the comprehension-based refactoring. Those are just like, it takes a lot more mental energy to do it, but they're all doable. I know everybody in here can do it. And the more complex are the planned, changing interfaces, new versions. I say new version there on purpose because I feel like the better strategy when you're doing a big refactoring is find a way to version it so that you can stand up the new version slowly and sunset the older version versus having to start fresh, but that actually takes a lot of time. And just a reminder, next time I see you guys starting a new feature enhancement, I'll be watching to see if you guys do anything differently. I say that jokingly, of course. All the links and resources we talked about, I'll send out after this, but I tried to give you a link to the book. One of the workflows of refactoring is that YouTube video. Refactoring catalog is that ugly site I just showed you. And there's Refactoring Guru. It looks like the guy stole pretty much every thing in this book and then put training on top of it. It's neat. But I didn't want to call him out because I knew he had stolen it. And the last really interesting thing, this is a refactoring technique. It's called the macchiato method. It's really fascinating, but it's more of a technique used in big refactoring. You should read about it. It takes like 15 minutes to read about it, but it's just it's a thought provoking thing. So that's all I have. I have one more slide on big refactoring, but I don't really want to share it because I don't like promoting big refactoring. But yeah.
So it's not a question, but I have a little bit of, I guess, probably a comment. You mentioned that the definition of legacy code is you don't have automated test coverage, which means most of the things I tend to work on tend to be legacy code, where there's manual testing. And it seems like one of the secrets to being able to refactor freely is really good communication with your QA department.
Yeah.
That, you know, if I go in to fix a bug and I fix something else, I may have broken something on accident with my refactoring. I sure hope not, but to have that open communication to say, hey, while I was in there, I touched this. Please test that a little bit better. I know when I've had that with like QA people, I feel much more confident to go in and just clean stuff up. I'm not afraid of breaking stuff.
Absolutely. That's a very important point. Is like as we choose to do these things, it's not only communicating that we did it, it's also trying to make sure we have the approval to do it. But it's definitely on us to make sure we're communicating impact, especially if they don't know about it. And it's a good safety net too. Like you shouldn't be using QA to vet you did things right, but definitely you need to make sure you're in lockstep. So it's a good call out.
Questions from people watching?
Okay. Silence. Awesome. All right. Well, thank you all for attending. Hopefully this was useful. Feel free to reach out with questions, and I will send out the deck.
Yep. And I will, once we're finished here, I'll make sure this video gets uploaded, so it'll be accessible. We'll put all the links in there as well in the description. So yeah, thank you everybody for watching, coming out, or watching it later after the fact. Stop by in April, second week in April, and Hayden will have his dev talk as well. We'll send out some reminders and more information about that as it gets closer. See you guys later from Unboxed at our new location.
Such a tool, like they have like a built-in interface for you too. So like as you change stuff, it like updates